So in the earlier session, we have discussed about SSL in detail, like we understand about cryptography, different types of cryptographies like symmetric and asymmetric cryptographies and SSL handshakes and all in detail, right? So in this session, let's see how this SSL communications are used in FI. When it comes to FI, there are two types of SSL communication. One is client SSL communication and the other one is server SSL communication. And the client SSL communication is also referred as SSL offloading or SSL termination or SSL or client SSL. Okay, which means the communication between the client, the end client, the outer world client to the FI in the data center will be encrypted. Okay, the communication between client from the outer world or the client and the FI in the data center will be encrypted. This communication will be encrypted. However, the communication between the FI and the backend server is decrypted. Okay, so this is called client SSL, whereas if it is in server SSL, uh, the communication between FI and server also will be an encrypted thing. Apart from communication between the client and FI, here also it will be the communication between FI and the server also is an encrypted communication. Okay, so the main advantage of using client SSL or SSL offloading is uh, it boosts the performance of the server. Okay, it makes the server to perform efficiently. The reason why, because see, if we want to establish end-to-end SSL communication between a client to the server, yeah, we can. Yeah, server is also possible. Server is also capable of handling SSL transactions, SSL communication, right? The server is also can handle the SSL handshakes. But when we put those kind of stuffs, the SSL handshakes or SSL communications over the server, then it overloads the performance of the server, because as per the requirement, the server is to serve the web application, web request only, right? But it's not that it cannot handle SSL, it cannot perform SSL handshakes and communications. Yes, it can do it, but it is an extra task, right? So it will overload the performance of the server. Okay, so if we make the server to handle the SSL directly, then it need to put extra effort, and which may degrade the performance of the actual server. And that's the reason FI on behalf of the server, he's handling the SSL part. Okay, due to which it is reducing the overload of the server, and it's making the server to perform efficiently, fastly, and uh, in the safe mode also. Because ideally the idea is both FI and the server is in the data center only, right? So but the the communication between the client from the outer world to the FI, that need to be encrypted. However, both FI and the servers behind the FI are in the data center only. So mostly your servers or whatever the network component, whatever the configuration objects in the data center will be in the secured environment. So that's the reason it is in the decrypted, or we are not using the SSL communication between FI and server, because it will overload the performance of the server, and all those tasks is taken care by FI. So whenever a request it's initiated, or whenever a request is coming from a client to FI, it will be coming as an encrypted format. Okay, and once the request is received in the FI, it will be decrypted in the FI, and it will be forwarded to the server. Okay, it works on behalf of server. It reduces the workload. Okay, and it decrypts and forward the request based on the load balancing algorithm. Once the server receives the request, it responds back to the FI, and again once FI receives the response from the server, it encrypt, and it sends the response in the encrypted format. So basically the communication is in the encrypted format between client and FI, and it is in decrypted format between the FI and the server. Okay, so due to which it speed up the process of the server, and the performance is ideally the performance is good, okay, because of this. This is what referred as SSL termination or SSL offloading or client SSL. Let's discuss about this in lab in detail, okay. So before getting into it, before enabling or before configuring SSL communication between this, just to compare, let's first without enabling or without configuring SSL, uh, let's access from the lab and analyze the Wireshark packet capture to understand the difference, so that we can understand once we enable or configure SSL, it would be easy for us to understand the packet, right? To understand, to analyze it. I'm sorry. So HTTP test virtual server. This is my virtual server, and it is using port 80. And currently, I'm not configuring for SSL communication. It's just I'm having a default HTTP communication. Okay. So let me start a Wireshark packet capture just to show you how it works before configuring SSL offloading, and how it works after enabling SSL communication or SSL offloading. So basically, I have two captures here. As you know, one is to capture the communication. This is to capture the communication between my client and my FI, and this is to capture VMnet 1 is where my backend server and my FI is communicated. Okay, so two captures are there. One capture shows the communication between my client to FI, and the other capture shows the communication between my FI and the backend servers. Okay, so now let me close all the existing sessions. Okay, closed it. Maybe let me open access from my third client. Okay. So as I said earlier, I have a three clients: client 1, client 2, client 3, and I have an FI. And behind this FI, I have a three servers: web server 1, web server 2, and web server 3. Okay. So I already started the Wireshark packet capture just to show you how it works without SSL communication. Okay. I have not yet configured any SSL communication now. See, this 172.16.0.30 is my virtual server IP. Once I hit it, the request is redirected to my second web browser, which is 10.10.10.20. Okay, based on the round robin algorithm, I believe. Okay, so let me go and show you the Wireshark captures so that it will be easy for you to understand and compare it once we have SSL communication. So this is VMnet 8, and let me bring this VMnet 1 communication captures also on the right side. Just to okay, I'm sorry. Okay. So this is my communication between client and FI, and this is my communication between FI and the backend servers. So HTTP, or let me go with TCP three-way handshake. Okay, here elsewhere. Okay. See, if you see here, as I said, this is the communication between my client and server. 172.16.0.11, it's my client IP address. My client user IP address, okay, and 172.16.0.30 is my virtual server IP, which is configured in the FI, right? So once I initiate the HTTP request, you can see that there is a three-way handshake, and post to the successful three-way handshake, my client requested for HTTP using the HTTP GET method. He requested for the HTTP page, right? And once this request is initiated here, uh, as it is in the full proxy setup, there is in two different session. One session is between client and FI, and the other session is between FI and the backend server. Okay, and as I said earlier, I have enabled NAT. Okay, I have enabled our NAT automap method. So this client source IP address 172.16.0.11 is translated to the self IP address 10.10.10.100. Okay, and this request to it is in communication between the server and the FI. Okay, so 10.10.10.100 is the IP address, self IP address of the FI, and 10.10.10.20 is the backend server, second backend server, web server 2. Okay, so as like the same here, you'll be seeing a three-way handshake between my FI and the backend server, and post to the three-way handshake, TCP three-way handshake, you are seeing FI requested for the same HTTP request which is initiated by the client. Okay, and he's asking for the same HTTP request, and now the server is responded to it, he gave it. Okay, and once FI received it, FI received that HTTP request from the actual backend server, and it forwarded it, or it showed it to the client. Okay, so this is how the communication happens without using the SSL communication, or without using SSL or TLS, right? So this is the decrypted communication, I would say. If you say, I can also, I'll just show you only the HTTP. Now, if, as it is an unencrypted or a decrypted communication, when we are searching with HTTP, we are seeing informations here. But once we enable SSL offloading, this side we may not see that. If we search with the HTTP, we may not see any information because it's not an HTTP anymore. It's not going to be an HTTP anymore. Okay, so this is how it happens. If you're not using any encrypted or SSL communication, it's just in plain communication. Okay, decryption, plain communication, I would say. So now what I can do, let's stop the, okay, we already stopped the capture, right? Then we may close it. And let's enable, or let's configure SSL offloading. So the first step is we need a certificate to do it, right? So we have discussed about it in the earlier session where we discussed about SSL. For this, we need a certificate. Okay, as it is a lab and we don't have any certificate purchased from the CA, okay, certificate authority, we can create our self-signed certificate here. Okay, so in order to create a self-signed certificate, you just go to System, click Certificate Management, and click Traffic Certificate Management. Okay, once you click here, you will be redirected to this page. Go to, if you have a certificate, you can import from here, or you can create it by here. You need to give the name. Okay, maybe I can give test SSL certificate. And as I said, I don't have, as it's a lab, I don't have any certificate issued by the certificate authority, so it is a self-signed certificate. If in case you have any certificate which is issued by the CA certificate authority, you can give that certificate authority and all those stuffs. Okay, but it isn't self-signed certificate from the box itself. And here the common name, usually you need to give the URL of your the web application, the URL which you have created in the your virtual server, right? So generally you need to give that here. Okay, because you're getting the certificate for that URL name only. Okay, so as I don't have any DNS resolving, I am just using the IP address here in the lab, so that I'm just having any common name here. Okay, as like the device name itself, newltm.com. Okay, but if in case in your production, if you are trying with any web application, you need to give the URL name here. And whenever you're requesting for certificate, you need to fill all those informations, right? The organization information, locality, provinces, states. So this information you need to fill whenever you are getting any certificate. As it is a self-signed certificate and it's for lab, I'm not filling anything. And basically by default, all the certificates is valid for 1 year. And also, yes, you can, whenever you are buying from a CA, you can get it for 2 years as well, or 5 years based on the contract. Okay, so as it's a self-signed certificate, I'm just creating it. So my self-signed certificate is created here in the name of test SSL certificate. Okay, so now I have created a self-signed certificate here. Then point number 2, I need to create a profile. Once I created the certificate, So to create a profile, go to local traffic, click profile. So once you click profile, you'll be redirected to the profile dashboard here, and under profile you'll be seeing an option SSL, where there is a two options. One is for SSL and another is for server. Okay, as now we are doing SSL offloading, which is a client SSL, right? So you need to click client. Okay, so by default there will be some profiles, but I suggest you to create a new one, because in a production you'll be having a multiple web applications and each application will be having a different certificates, right? So it's not always suggested, or you cannot use one parent profile to all all the certificates. So you can create a new profile, maybe test SSL. Okay, I'm creating a new profile and inheriting the objects from the parent profile client SSL. Okay, so by default my client SSL, right, this profile is using this default certificate, but I don't want this use this. Okay, so what I'm going to do, I am modifying it and I'm adding the self-signed certificate that I have created. Test SSL is the self-signed certificate that I have created there, right? So once you created your certificate there, it will be reflected. So again, I want to use the same key, change. That's it, add it. I have added it. Okay, so like this, in a production you'll be having multiple web applications or multiple URLs. So whenever you are creating or whenever you want to have your own certificate or SSL communication for each virtual server or each URL, you need to create a new profile. Okay, because you cannot have one same profile with the one particular certificate information using for all, right? So it is always suggested to create different profiles for different certificates. Okay, so now what I did, point number one, I created a self-signed certificate, and here point number two, I have created a profile in the name of test SSL and associated that self-signed, create a self-signed certificate which I have created there here. Okay, and point number three, I'm going to associate this profile under my virtual server, and before that, very important, I need to change the port number. So earlier it was port 80, which is used for HTTP connection. Now I am making us port 443 because it should be an encrypted communication, right? HTTPS communication. So make sure that we are changing the port here as port 443, and then I need to associate that profile, the certificate profile that I have created here, to this virtual server. Only then it will work, right? So now what I have created, first one, I have created a certificate, a self-signed certificate, and then associated that self-signed certificate to a profile test SSL. Okay, and once I have associated the certificate to the profile, now I am associating the profile to this virtual server. Okay, update it. That's it, simple, done. So now what we have done, we have established an secure SSL communication between client to the FI. Okay, it's an SSL offloading because we have enabled SSL only between client and FI, because we don't want to put overpressure or overload on the server side, because as we know, both FI and server are in the data center, it's in a secure environment, and we don't want to have an encrypted communication between the FI and the server. So we have established a secure communication between the server and the client. So let's start the capture once again. Okay, as I said earlier, I have two captures. One capture is to show the packets between my client and FI, and the other one is to show the packet between the captures between my FI and the backend server. Okay, now let me, okay, last time I have used my client 3, right? This time maybe from client 1. I'm opening my browser, and before that I would like to show you my IP address. IP config. See, my IP address is 172.16.0.9. Fine. So this time let me try 172.16.0.30, but it won't reach, or the request is not completed, it's not connected. The reason being that is this time I have initiated the communication using HTTP, whereas my virtual server is now listening to the port 443 using for the service HTTPS. Okay, as this communication is initiated with the service HTTP, this request is not connected. Okay, maybe if I put HTTPS, it should connect. See, it's connected. One 72. This error is because of the self-sign certificate, but still it's working, right? So if you see, we are using HTTPS communication, and the request is redirected to the web server 3. Okay, let's analyze the captures. Okay, let's stop it. Okay. Okay. So this side, it is my communication between my client and FI, and this is the communication between my FI and the backend server. See, last time I have shown using a filter HTTP. See, this time we are not seeing any results if we filter with the term HTTP, because it's no more a HTTP communication between the client and the FI. It is an SSL communication, TLS communication. And at the same time, if I filter with HTTP, here you'll be seeing that information, because the communication between the FI and the backend server is not an encrypted communication. It's an ordinary plain communication. Okay, so that's the reason here when we try to filter with HTTP, we are seeing this information. Okay, let me filter with TLS. See, so this is how SSL communication works. If you see, the this is my source, right? 172.16.0.9 as I showed. This is my client IP address, and 172.16.0.30 is the IP address of my virtual server. Okay, so you'll be seeing SSL handshake as like my client says hello, and with the, if you see, as we discussed earlier, client will send an hello, and this hello message, it tells about the TLS version it's using and other parameters that's required for the TLS SSL communications, right? And post to that, now the client, sorry, the server will send an hello message as a reply, and in the reply hello message it will send its hello version, the certificate informations and public key informations and more. See, it sends its certificate and the public key informations and so on. So once this client receives the certificates from the server, the client usually it will check with the public CA or the CA, okay, to understand if the server is the legitimate one. Okay, and if the certificate authority tells this tells the certificate is authorized or the right one, then it will proceed further, or else usually it will reject the communication. Okay, as we don't have any CA here in our environment, we are just using the self-signed certificate. Now what happened, it considered that as an legitimate, and it created, the client created a session key, and it encrypt the session key using the public key that is generated and shared by the server here. Okay, so that is how we have discussed it earlier in detail about this SSL handshakes earlier in the previous sessions, right? So this is how it happens. And post to the successful SSL handshakes, they they shared their session key, and both of them have the session key, and using that session key, now they have transferred the data. So basically, this is how it works. It's an see, application data using 443, port number 443. However, the communication between FI and the backend server, it is using plain transaction. It's not the SSL transaction. If you want to see, I can show TLS. See, when I filter with the TLS, we are not seeing any entries here because we are not using any TLS between the my FI and the backend server. It's in plain communication, the decrypted communication, or the normal HTTP communication using port 80. So it's using port 80 only. But however, the communication between the client and the FI, it is an SSL communication, the secured communication using the protocol TLS version 1. So this is how SSL offloading works. So as I said earlier, basically SSL offloading is um, uh, to reduce the workload of the server. FI will do all the SSL works, okay, on behalf of server. So the communication between the client and the FI will be an encrypted communication, and the communication between the FI and the backend server is a decrypted communication, as we seen in the captures. Okay.